All right, so today we're going to get into what we call linear inequalities. So we've been practicing graphing equations. It's been a couple weeks because we were practicing solving equations using substitution and elimination. Now we're going to go back to looking at it graphically, because with an inequality, now we don't have one specific answer. We have a range of answers that are okay. Because remember, an inequality is anything greater than or less than a certain number. So that can be applied to a line when we graph it. Anything greater or above that line, anything less than or below that line. And above and below are kind of loose terms. I'll explain that a little bit more when we get there. So we're going to graph the solution to the two. So we're going to graph these two lines just like we would if it was y equals mx plus b. So for a moment, we will ignore the greater than or less than symbols. But they do mean something when we get to the actual graphing. So we're going to use slope-intercept form, just like I was talking about. So y equals mx plus b. So remember, the slope is m, that's what's being multiplied by the x, and the y-intercept is b. And this is always our starting point. So we start at the y-intercept, that number being added or subtracted, and the slope tells us where to go from there. Either, up, down, and then right or left, based on the fraction or the number that's given there. So the inequality sign, because it's not an equal to. So when we had equal to before, y equals mx plus b, that was a solid line, because we know that the equation is equal to this line. We have to pick a point on that line in order for it to be a solution. Well, now we have an inequality, and we have quite a few different options. So if we have just less than or greater than, it's a dotted line. And what this means is it's not actually part of the solution. It's kind of like a starting point. So it can be either above or below a certain point on that line, but it can't be on the line itself. It's just a starting point. The solid line is when we have less than or equal to or greater than or equal to. So we actually see the equal to sign under, so we still have some of that equal, like we did with the y equals mx plus b. We just also have the inequality part of less than or greater than. So once we've identified, our pieces, then we can graph the lines. And it does matter if it's dotted or solid. That will get it marked wrong if you don't do the correct type of line. And there's a way to swap that on Alex. It's a really cute little tool that's on there. And then to decide which direction you're shading, you choose a point to test for both lines to determine the areas to shade. If the point is true, you shade on that side of the line. Otherwise, you shade on the other side. Okay, so when we're doing this, we're going to first look at, here are my slopes and here are my y-intercepts. So immediately I already can start graphing. This is in y equals mx plus b for both equations. Yay! I do have to choose two colors once I start my shading process. So for my first line, you can see I went up to 3, because that's my first line, positive 3. And then for my slope, it just says 4. Remember, if there's no number underneath, that means a 1. So I'm going to go up 1, 2, 3, 4 over 1, and there's my point. I can do this multiple times if I want to, especially on paper. You want to be nice and neat about this. On Alex, you're not going to have to worry too much about that. Now, if you notice, it is a dotted line because it's just greater than. Okay, so make sure you're paying attention. Is it greater than, less than, or does it have an equal to sign under it? So in this case, it's just dotted. So I'm going to go to my next line here. So I chose red because you can see my red line here. So my next line, I'm going to go down to 5. That's my starting point, -5. And then my slope is -2. Remember, since I don't see the fraction, it's over 1. So I'm going to go down 2 to the right 1. And there's my point, and I can put a line. So now if you notice, this line is solid because it's less than or equal to. So it's a solid line. So I picked my colors. Now I'm going to choose a point to shade. If 0, 0 is not on the line, definitely choose 0, 0. It's a very easy point to test. So here I'm testing the first equation here. So I have y is 0 and x is 0. So you can see I've plugged them in. And I'm just seeing, is it true or is it false? So 0 is greater than 4 times 0 minus 3. So 4 times 0 is 0, which cancels. So I have 0 is greater than -3, which is true. So you can see I immediately went through and I shaded on that side. Since it's over here, the whole side of the line gets shaded red. Because that's true. All of that red is possible solutions for the first equation. So the second equation, I'm going to do the same thing. So I'm going to do that down here. I'm going to plug in 0, 0 again. So I'm using this second equation here, but my y and my x are zeros. So negative 2 times 0 again is 0, so that cancels out. So I have 0 is greater than negative 5, which again is true. 0 is greater than negative 5. So I'm going to, since this point is on this side for the yellow line, I'm going to shade everything up above here. Okay, so anything where the two shades are crossing, this is actually my favorite part because we get to color a little bit. And if you use like highlighters, which is the clue I'm giving you here, it makes it very easy to identify where the two colors are crossing. You do not have to use highlighters. If you're just using a pencil and you shade it in one direction, and then for yellow you shade it in another direction, and you might have learned this in your art or drawing, it's called cross-hatching, you will definitely see where the two areas are mixing because it'll be much darker with the two different line directions. But hey, if you have highlighters, then they mix together. If you use red and yellow, you'll get orange. If you use red and blue, you'll get purple. So very easy way to mix those colors so that you can see how they're coming together. If you use green and yellow, you'll get blue, things like that. So you can definitely see those solution areas very quickly. All right, let's try one more of these. So we're going to graph the solution. So again, this time they're not solved for y, so in order to graph them quickly, I'm going to solve both inequalities for y so that I can use slope-intercept form. So again, we're just kind of filling that back out again. It's y equals mx plus b, m is my slope, y is my, b is my y-intercept, and we have the same rules for dotted or solid lines. If it's less than or greater than, it's dotted. If it's less than or equal to or greater than or equal to, it's solid. So those rules haven't changed. And it looks like I'm going to have one of each. I'm going to have a solid line. I'm going to have a dotted line. And then we're going to graph the two lines. We're going to choose a point. If 0, 0 is available, we'll choose that one because it's just an easy point to do to determine which way to shade. So again, if it's true, we shade on that side of the line. If it's not true, then we shade on the other side of the line. Okay. So let's go ahead and we're going to start solving. So I'm going to add, I want to get y by itself. That's why I'm going to take this negative 3x, I'm going to add it to the right side. So then I have 5y because the 3y minus 3x cancels out. So 5y is greater than or equal to 3x minus 5 on the right side. So now I'm going to divide by 5 on both sides because I want that y all by itself. So 5 divided by 5 cancels. And on this side I have 3/5 x because 3 divided by 5. And I also have to do 5 divided by 5. Don't forget, you're dividing everything on that side by 5, not just one piece. So here is my equation for my red color, and I went ahead and chose red on that one. All right, so for this one, I still want to get y by itself, so I'm going to subtract 7x from both sides. And so I end up with 7x minus 7x cancels, so 2y's by itself is less than 7x plus 4. So these two just kind of move to the right side. Now I'm going to divide by 2 on both sides so that I can get y all by itself. 2 divided by 2 cancels. And on the right side, I have negative 7 divided by 2, so negative 7 halves. And then 4 divided by 2 is 2. So again, make sure you're dividing everything when you move that piece. So now I have my two lines. I can go ahead and start graphing. So I'm going to start at my y-intercept. So here it is, negative 1. Then I'm going to use my slope. So I go up 3 over 5. And then I decide on my line. So since it's greater than or equal to, it's a solid line. I don't have to change that. So I'm going to do my second line. I'm going to start at 2. So there's my y-intercept. My slope is negative 7, 2. So I'm going to go down 7, right 2. And now I'm going to graph my line, but I do have to pay attention to that inequality sign. It's just less than, so it needs to be dotted. If you left it solid, it would mark you wrong because that is not included in the solution. All right, so I can see 0, 0 is not being used. It's not on one of the lines. So now I'm going to choose 0, 0 to test. So here's my first equation. And I'm going to plug in 0 for x and 0 for y. And so with this case, I have 0 is greater than or equal to negative 1. Well, that's true. So I can shade above because that's where 0, 0 is. That's a true solution, so everything on that side is true. All right, so now I'm going to do the second equation. And again, I'm going to plug in 0 for y and x. And this multiplying by 0 makes it go away. It becomes 0. So now I have 0 is less than 2. Well, that is also true, right? 0 is less than 2. So I can shade, everything on this side of the line, because if this is true for the blue dotted line, then everything on that side is true. So now you can see this kind of purpley area. That's the solution that's true for both equations. So the red is only true for red, the blue is only true for blue, but where they crisscross, where they become purple, it's true for both systems. So, all right, so that was solving systems of inequalities. So hopefully you had fun coloring and that helped, and I will see you on the next video.